are you, everybody who is watching this video? My name is Olenjolai TAYAI single. Simply call me Olenjolai. I'm from Tanzania, beautiful country in the eastern of the African continent. For those who don't know where Tanzania is, we are warmly welcome to all the foreigners and even the inhabitants of the United Republic of Tanzania. I would like to welcome, whether you're an international viewer or a national viewer, you're warmly welcome into the online undergrad, into the online Diploma Polytechnic Institute of Tanzania. So we are very happy to have you today, and we have a piece of information that they prepared a special knowledge in concepts of basic engineering and scientific mathematics. So stay tuned. So I would like to welcome you first of all into our online institutions, that is called the Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. Simultaneously, because I'm teaching mathematics, so I will teach you about simultaneous equation, I will take these moments to welcome you into one of our YouTube channels. We have 6 YouTube channels, we have 6 online schools, which is called the Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. You can search this in the search engine of YouTube. So I'm very glad to be with you, and I'd like just to spend a couple of the minutes to explain to you about the visions, because visions is powerful, man. Visions is the one that always, visions precede plans, and visions is more important than plans. So this is the vision that we have in online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, right? So God has given me an assignment, and this is purpose, right? He said that I have a responsibility to prepare, incubate, teach, train, and even mentor and lead some ordinary diploma students who will be ready to take their classroom instructions in basic engineering and scientific mathematics, in combining with, which we call the fundamental, right? Fundamental concepts or fundamental knowledge, combine it with the instructions that they used to get in the classrooms in the core courses, whether in civil engineering, for example, in electronics, analog electronics, it's a core course. And combine the classroom instructions with the knowledge from the Word of God that's written in the Bible, in the Holy Bible, in order to solve real life problems. So simply, I mean that we are training, we are teaching some special students who are ready to take the classroom instructions combined with the knowledge of the Word of God to solve real life problems. So the visions is greatly, or it has 3 main parts. And this is biblically. If you read the book of Genesis, chapter 41, right? And then you find that from verse 37, 38, and 39, you'll find the visions that I'm declaring right now. That's what has been written in my mind, and even I want you to be, this concept to be written in your mind. So when I mention about Bible, I don't mean the Bible. I'm teaching only Christians. No, I'm teaching any religious, and even those students who don't have religions, because the Holy Bible is not for the Christians. However, the Christians are the one that meditate it. So it seems like confusing, but don't worry, because we have a special departments that call the Kingdoms of Heaven, and we are going to explain and clarify these secrets so that you have to own and have a valid information from the facts, from the truth, right? So that the vision. So our main goal in this, in online Diploma Polytechnic Institute of Tanzania, is not to teach students in order to pass their exams. However, that's one of our specific objectives. So our main objective in online Diploma Polytechnic Institute of Tanzania is to incubate, is to teach students on how they can solve real life problems. So our achievement is, once we see our continuing basic technicians and even our graduate basic technicians are really solving the real life problems, whether it is small scale real life problems, it means that it may be from you are solving your own problem, or you're solving your family problems, or your street problems, or your village problems, etc., etc. So that's our joy, and that is even the fruits. We say that now the work we've been doing, it has produced, it has gave out the fruits. However, that what I'm telling you, it can take some time, maybe some months or some years to achieve it, and even to build my mind, because my intentions and even my training and my teaching, they're gonna deal on changing your mindset and way of thinking. So you have to think it differently, and acting differently and learning differently. So everything that is going to change, believe me. And another one of our specific objectives that we like to make all our students to love, first of all, basic engineering and scientific mathematics if they have lost that love for some time. Again, the second specific objective is we like also to make sure that all our students understand, because you can love mathematics but you don't understand. So we'll be using different teaching aids so to make our students they understand the subject of basic engineering and scientific mathematics. So we have some departments. One of the departments is called the Basic Engineering and Scientific Mathematics. In these departments, currently we are teaching 6 modules or 6 courses. One of the courses is called the Algebra that I want to teach you today, but also we have other 5 courses. And this is it's a course which has been in Tanzania by using the curriculums of the NACTE, National Technical Council for National Council for the Technical Educations. So it means that this the course or modules which has been taught to the first year ordinary diploma students. So that's why that I say year of study is first year, and the specialty is in first semester. So again, if you are, I know that you are a first year ordinary diploma student. I would like to welcome you into the ordinary diploma educations. Stay focused, have your own visions, have your own destiny, concentrate and have discipline in case of learnings. Take worth and take honor, and you have to honor all the teaching. You have to honor this teaching that I'm providing to you. You have to honor the teaching from your parents. You have to honor the teaching that you are receiving from your guardians, from your teachers, and even from your classroom teachers, and even the leaders of your community. So you have to honor them. So remember that I'm going to use kind of curriculums of NACTE, however that basic engineering and scientific mathematics is universal. So whether you're international students, you are learning these contents in Nigeria, or maybe you're learning these contents in the United States, or you're learning these contents in Canada, you're learning these contents in Bahamas, you're learning these contents in the United Kingdom, you're learning this content from Asia, you're learning these contents from maybe Indonesia, from maybe South Korea, or from Israel, or from China. You're learning these contents from Australia, regardless of where you are in the world. These contents are very important, and you need them for the rest of your life. And you have to think how you can apply these contents. So today we have to continue. We have a session, and this is lecture 5 of indices and logarithms. That's one of the topic. So we have a quick review. We want to link lecture 5, which is problem solving in indices and logarithms. So I hope that you've enjoyed the problem solving of lecture 4. So in our YouTube channel, you can find that we have lecture 00, which is general introductions of basic engineering and scientific mathematics, right? So we gave you so many informations about registrations, about even the visions that you have, what problems are you solving, because I'm a product of both areas. I'm products of the classroom instructions, I'm also products of the Word of God. So again, we began to teach you about lecture 01, when we taught you basically about indices, right? And then we taught you against lecture 02, which is titled also about, this is general introductions of indices, right? And then this is called general introductions of 40 of logarithmic function. And then we taught you lecture 3 when we taught about laws of logarithm, laws of common and natural logarithm. And then in lecture 4, we taught you about problem solving. Say problem solving. So in case you find that I'm teaching you quickly, you can review this video and watch it several times until every piece of information is in your mind. Remember, get prepared that you are going to understand basic engineering and scientific mathematics even if that you don't want to understand. Because I won't teach you how to cram. I will teach you how you can solve. I will teach you and make sure that I transform your mindset from the belief that mathematics is a disease, is a national disease, and cancel your mind that and make mathematics is no longer a national disease, but it's a great tool to solve real life problems in our nations, and even including Tanzania. Okay? So I ended lecture 4 with what? Problem solving, loads of logarithms that we've been dealing with. I ended lecture 4, if you do remember that, with homework 4, and this was example 8. So let me write it. The questions ask you that find the value of x, find the value of x which satisfies or possibly that I wrote maybe in another piece of instructions, don't worry about that. Satisfy the equation. Which equation? This one. Satisfy the equations log of x base 2. This is equal to what? This is equal to log of what? Of x plus 6 base 4. So, have you done this question? Tell me in the comment sections, please. Have you done? If you did it, I believe that you enjoyed it. It's very simple questions. But let us do corrections, because I know that maybe some of the students did it also, and our aim here is to help you. So corrections of homework 4, so you can check whether you are right or you're not right. So question 4, which was example 8. So, solution. So first of all, we have been given a log of x equations, logarithmic equations, which comprises two parts, left-hand side and the right-hand side. So observe the given problem. So when you observe the given problems, especially on the parts of base, the two logarithmic functions have different bases. The first one has a base of 2, the other one's base of 4, not base of 10, right? So under this case, means that you have to be careful. First of all, in order for you to simplify and find the value of x, you have to make sure that the base of two logarithmic functions of left-hand side and right-hand side should be the same, right? So if that's the case now, we think that the first step, we say, let us consider left-hand side. So suppose that this is question 1, or 40 of equation 1. So when you consider it, you have log of base 4. This is x plus 6. So from there, again, we say that you have to recall one of the law of logarithm. And this law of logarithms is, we say log of a base b. This is equal to log of a base 10 over log of b base 10. So this is equal to fraction, right? Fractional logarithmic function. So if that's the case, now we say that log of what? X plus 6 base 4. This is equal to what? Log of what? X plus 6 base 10 divided by log of 4 base 10. Right? So if this is the case now, so let us proceed. I believe you're enjoying the beauty of basic engineering and scientific mathematics. So if this is the case, then now we say that this is log of 4 base 10. So we can simplify this denominator. So if how we simplify, so log of x plus 6 base 10, this is equal to what? This is equal to log of 2 base 10 square. Log of 2 square base 10, because 2 times 2 is equal to 4. Right. So great. So that's the case. So then we say that this is log base 10 of x plus 6. And here, so by using the laws of logarithms again, we have 2 log of 2 base 10. Right? Again, if that's the case now, we can keep on enjoying. So we have fractions now. And then we have log of what? We have log of x plus 6. And then we say that log plus 6 base 10. And here in denominator, we have log of 2 base 10. So remember that this one is equal to what you've been given. This is equal to log of x plus 6 base 4. So we can consider this one as the second equation. So it means that we found that. Okay? So we found that. So you can keep on simplifying. What kinds of the simplification we say? We have to say, but log of x plus 6 base 10 as fractions. Now we restore in another, or we express in another logarithmic format. So this is equal to, because of the same base, is equal to what? Log of x plus 6 base what? Base 2. Right? So base 2. So then, if this is the case, so suppose that this is equation 2, and this is equation 1, equation 3, excuse me. So you have to substitute equation 3 into equation 2. Okay? I believe that you're enjoying the beauty of basic engineering and scientific mathematics. So then, so if you substitute, so this will be the second step. In the second step, you say that substitute equation 3 in equation 2. In equation 2, right? So to substitute it, we have now log of x plus 6, right? Or we say that log of, for this one is equal to a half log of what? Log of x plus 6, and then base what? Base 2. So this is equation 4. It's a new one. It's not existing there. So then we go for the third step. So now we have equation 4. We have already simplified this one. So at least that we have something. But we can express also this equation 4. Let me just keep on simplifying it. So again, we say that this is equal to a half. No, this is equal to log of x plus 6 power half base 2. So what is it? So this is log of x plus 6 base 4. So this is what we say equation 4. Right? So then we go for the third step. We have to enjoy solving basic engineering and scientific mathematics. So we go for the third step. The third step, we say that let us substitute what? The simplified equation 4 in equation 1. So to substitute there, on left hand side, we had log of x base 2. This is equal to what? This is equal to log of x plus 6 power half base 2. Right? So great, that is good. So now we have the same base. So you know what is going to happen? So we can say that now we divide this log, mean that we can cancel, right? Because of the same base, these are the logs of the same base, then we say that we can cancel them. And then equate this what is just like exponent, right? Just like exponential function. The same base, so you can cancel them. So if we cancel them, so we say that you can cancel log of base 2, log of base 2, remains with x is equal to what? X plus 6 power half, like this one. So then we have to multiply by 2 to raise by 2. It means that we have to multiply the exponent by 2. So then right now we have x squared is equal to x plus 6. Why? Because this 2 will cancel this one. So if that's the case, now we can express these equations now in quadratic form. So x squared minus this one, this is equal to 0, and this is equation 5. We are looking at the value 40 of x. Tell your neighbor, enjoy the beauty of engineering and scientific mathematics, basic engineering and scientific mathematics for ordinary diploma. Okay, so now you can use our scientific calculator. So we think that the first step, because I want you to have a clarification, use your scientific calculator that I told you that you can order. Okay, you can order the scientific calculator from online Diploma Polytechnic Institute of Tanzania, right? So if you use to solve what? So to solve equation what? Equation 5. So this is our scientific calculator. In case that you don't have it, go to the descriptions of the video and then order. We are providing social tools, and one of the tools that we are providing, so learning tools, is a scientific calculator, which is the original one, right? So then if you have your scientific calculator, how can you solve this one in case that you don't know, because I know that you are from possibly Form 4 and you are not aware about this one. So you just press the mod, first type for one, first type you see compounds and complex, then you come against what standard, so you have standard registration base, Then you go to equation matrix vector. So this is equation matrix vector. So you know what happens that here you press the mod 3 times. So choose these options of equations. Then you have to ask yourself, are you solving 2 unknowns or 3 unknowns? No, we are solving a quadratic equations of degree of 2. So you press this side of this replay button. So degree, so 2 or 3. So how many degrees? What the highest degree there? The highest degree is 2. So you just press 2. And then you've been asked the A. A is the coefficient of x squared, which is 1. And then you've been asked the B is the coefficient of x, which is -1. And then you've been asked the C, which is a constant number, it's -6. Then you get x1 is 3, and then x2 is -2. So therefore, so we find that the first value of x is 3, and then the second value of x is -2. So you have to test, right? So you go for the fifth step. So the fifth step, we say that test what? Test x1 and x2 in equation 1. So if you test it, we had what? Log of 2, log of x plus 2, is it equal to the log of x plus 6 plus what? Plus 2 plus 4, right? So, well, so let us think on log of 4. Let us take the positive number, because there we consider a positive number, right? So if you consider a positive number, we want to know log of 3 plus 2, is this equal to log of 4? So this is the question mark. Log of 4, then here we have 3 plus 6, which is 9, right? So good. So it's very simple to prove this one. You know how? Log of 3 plus 2, and this is log of 40. Log of 9 plus 4. And I told you that this one also is corresponding to what? Is corresponding to a half log of 9 plus 2. If you don't remember, I told you, right? And then we said that log of 3 plus 2, this is equal to what? This is equal to a half. Then we have what? We have log of 3 square plus 2. So if you bring this one, so you say that we have log of 3 plus 2, this is equal to a half times 2 times what? Times 2 log of what? Log of 3 over 2. So is it equal? So these 2 and these 2 cancel. So you find that log of 3 plus 2, this is equal to log of 3 plus 2. So that is valid. But now when it comes to the -2, this will be true if express every logarithmic function in exponential form. Because if you take log of -2, it does not exist. Log of -2 does not exist. So therefore, simply we say that the actual value of x, which satisfies the given equation, is equal to what? To 3. Then we are done. Okay? So let me take that was example 8. Let me take you into example 9 quickly, so that you enjoy. And I have to teach you in order to love. My intentions of teaching the classroom instruction is first of all to reduce the stresses that in your mind. So now let us solve another example. This is example 9. Example 9. And it's a little bit now concept, okay? It's a little bit concept. And the question asks you that find the value of x. Find the value of x in this equation. Log of 11 plus x. This is equal to what? Log of x plus 11. Okay? That's log of x plus 11. No, excuse me. Plus log of 11 plus x plus log of x plus 11. And this, the answer is equal to 22. That's the question. You see? So you've been given, on the left hand side, you've been given 2 terms in this logarithmic function or equation. So the first one, log of 11 plus what? X plus log of x plus 11 is equal to 22. So you see the base is not the same. So if the base of logarithmic functions is not the same, then you have to make sure that you make these bases the same in order for you to simplify them by using the laws of logarithms or laws of algebra. So let us solve together, because I'm here to help you. Solution. Okay, so the first step. We have to think. We have two options there. We can change. Okay, we can change. It depends the way that you are dealing with. We can change these logarithmic functions from. We can change the base of this logarithmic function from x into 11, or we can change the what? We can change the base this base 11s, base of 11 in these logarithmic functions to become x. So you have two options. But the best way is better if we make the base of our logarithmic functions to be numbers rather than letters or variables. So the first step, we say that let us change. Okay, let us change it. So let us change the base of what? Of the first term. Means log of 11 base x. Log of 11 base x, right? Into it. So this one to become log of 11 base x. How? So you have to recall. Recall the law I told you of changing what? Changing base. I said log of a base b, this is equal to, and we derive, this is all about lecture 3. This is equal to 1 over log of b base a. So I have changed the base now. Right? So if this is the law, then we say that now log of x base x, log of x base 11, it will be equal to 1 over log, excuse me. So you are changing log of what? Excuse me. So you are changing log of 11 base x. So this one will become as log of x base 11. Right? So suppose that the given equations already, this is question 1 and this is question 2. This is how we solve mathematics. So we go for the second step. The second step, we say that substitute equation 2 into equation 1. Right? Substitute equation 2 into equation 1. Substitute equation 2 into equation 1. Substitute equation 2 into equation 1. So substitute equation 2 into equation 1, then we have now 1 over log of x base 11, right, as we have already changed it, plus what? Plus logarithm of x base 11, this is equal to 22. Right? So you have already substituted. So we go for the third step. The third step now, after doing that, we say that we have to let us log of 11s, because now we have the same base. Log of x base 11s, this is equal to a, because we want to solve the problem. These are the steps that you have to follow. So 1 over a. So this one, on this side, will be 1 over a plus a. This is equal to 22. So simply 1 over a plus a. This is equal to 22. So the next step, you know what you have to do? This is equal to 22. So times what? Times a. And this one times a. And this one times a. So a and a cancel, right? So on this side we have 1 plus a squared is equal to 22a. So this is the quadratic equation. So then brings all the terms on this, on the left hand side. Plus 1 is equal to what? 0. So we go, this was the third step. Then we go for the fourth step. Do you enjoy the beautiful general scientific mathematics? So the fourth step, we say that solve A by using a scientific calculator. In case you don't have scientific calculator, you can use either graphical method, or you can use general formula. or you can use any other method, perfect square. Okay? So you can solve a quadratic equations by using different methods as we told you when you have been informed. In case you forgot, I'm also teaching basic mathematics for the Form 2 in one of our YouTube channels, in one of our online schools, and we have our YouTube channels. The online schools is called Tanzania Online Ordinary Secondary School, in square bracket Olenjolai. Our YouTube channel is called the Tanzania Online or Level Secondary School, in square bracket Olenjolai. In case that you have a young brother in that level or a young sister, inform them. So similarly, we'll be following the same steps as I said. So our scientific calculator, because we solved the example 8, is still in quadratic form, right? So it is asking the coefficient of A. What the coefficient of A there? It's 1. So 1, then you press equal sign. Then the coefficient of, that's the coefficient of A square. That's, we inserted the coefficient of A square. Then the coefficients of A, it's negative 22. That's corresponding to B. And then coefficients of 1, this is equal to 1. So we find that the value of A, which is on the scientific calculator, is what? A1. On the scientific calculator, it has been shown as X1. So you have to change. So this is 21.954 in 3 decimal places. Then so you have the second value of A2, which on scientific calculator is X2. So to know that, you press the equal sign. It is 0.05. So 0.04546. So 0.046. So those are the values of 40 of A. Right? Again, in case you feel from your heart that you want to offer God your free will in thanksgiving through these programs in order for you to participate in the running cost, so that in so many lectures of basic engineering and scientific mathematics will be in air. So you can send your free will in thanksgiving through that telephone number 0759745331. In case you want to do the bank transactions or sending your free will in thanksgiving from your bank account, read the descriptions below in order to know the information about the bank account. Okay? So thank you for your offering. Okay? So then if this is the case now, we go for the for the next step, for the fifth step, right? So for the fifth step, we let so we say that you substitute, okay, values of A in these equations. It was log of x base 11 is equal to what? To A. So let us begin with what? Log of x base 11 is equal to A, which is 21.954. So what are we looking for? Solve for x. So here we can solve for what? We can solve for x, because x is unknown. To solve for x, we go for the simple step. We say that suppose that this was equation 1, equation 2. So then suppose that this is equation 3. So we say that the sixth step, equation 3, and this one, suppose that is equation 4. So we say that express equation 4. I want you to understand, that's why I'm writing these instructions. Equation 4 in exponential form. So if you express in exponential form, the base is 11, the indices is 21.954, then the value is x. So now that's the value 40 of x. So the value of x is equal to 11 power 21.954. So you just use your scientific calculator. First of all, you have to clear it. So you have to press Shift, then clear all. Right? Afterwards, so we have to find what 11 power what 21, then point what. You have to also learn my course that explain about how you can use a scientific calculator properly. Right? So then we press the equal sign. So the answer you see is 7.467 exponent 22. So we find that this is 7.467 467 exponent 22 at the value of x. Okay? So if that's the case now, we say that, okay, this is one side. Then we have log e of x plus 11 is equal to what? X2, which is A2, 0.046. So if you express in exponential form, this is x to the power 0.046 is equal to x. So then we get the second value of x. The second value of x, it is what? 11 power what? Power 0.046. The answer is 121.7. 1.117. So these are the two values of x, and it's a assignment to test both of them, because according to my testing, both values satisfies what the logarithmic equation which we have been given. Okay, remember that if you want to offer our God, our Father, who is in heaven, who lives forever, who answers our prayer, who knows us, who has created us in his image and likeness, you are feeling thanksgiving for what he brought in your house without even paying for it, because these programs, these contents are forwards, right? So it's not even paying for it. So give him thanks, okay? And when you give him thanks, also you are handling. It means that you are supporting these programs, because in our YouTube channel, for instance, that's called the Online Diploma Polyinstitute of Tanzania square bracket Olenjolai. We are going to have more than 300 videos, so that plant your seed. So now let us go to, ladies and gentlemen, to example 10. Also, this is just to have as a concept. It's example 10. And this example 10 is fantastic question, right? So then the questions ask you that solve for x in the functions below. And this is 2 log e of a plus x plus, so you have to be careful in this question, plus log e of a plus ax plus log 3 log e of ax squared. No, a square x. A square x. A square x. This is equal to 0. So we say that 2 log a base x plus log a base ax plus 3 log a base a square x. Right? So you have to solve for x. So then we have solution. Solution. Say solution. So you have to, how many terms does this logarithmic functions comprise? It comprises 3 terms. Analyze each term. So log of a base x, log of a ax, 3 log of a base a square x. Because they don't have the same base, you cannot simplify them. So the first simplifications, you have to think on your own. How can you make all the 3 terms of these logarithmic functions have the same base? That's what you have to think as mathematicians. So to have the same base, even if that I change this base, and maybe, or even if that I simplify these bases by using the fraction or the fractional law of logarithm, it won't help me, because this is not equal to this, is not equal to this one. So the only alternative, the only method is to make sure that it will change the base of every term of this logarithmic function, right? So we say that we have being given 2 log of a plus x plus log e of a plus ax plus 3 log e of a plus a square x is equal to 0. Right? So if this is the case, what do we say? If this is the case, what do we say? We say that that is fine. So we say the first step, change. Okay, so suppose that this is question 1. Yes, that's why I wrote it. I wanted just to label this as equation 1. So this is question 1. So change the base of each term in equation 1. Right? So to change the base of each base, to change the base of each term in equation 1, how do we do? So we have to recall first of all the law. Recall law of changing base of logarithm. We say what? We say that you can have log of a base b. This is equal to 1 over log e of b base a. So if that's the case, if we change for each term now, straightforward, just because I know that you are competent enough, we say this will be 2, 1 over log e of x base a plus, then the coefficient is 1, so we have only 1 over what? Over log e of ax base a, right? And then plus what? Plus 3, and then we have what? 1 over log e of a square x base a. Right? Okay. Interesting. So now this will formulate that this is equal to 0, and this will make equation 2. Right. So at least that all the 3 terms have the same base of a, but you still have some problems. Right? Still have some problems. So what are the problems that we have? We have to simplify now. We have to simplify. We have to use the laws of what? The laws of logarithm, of product. So we go for the second statement. So we say that apply law of product, okay, in what? In second term, second and third term of equation 2. Where is equation 2? This one. How? Interesting. Look. So for the first term, we don't touch. Everything is clear. Everything is correct. 1, everything is well simplified. 1 over log e of x base a plus what? So for this term, here we have 1 over what? Log e of ax. This is equivalent to say log of a base a plus log e of x base a, right? Plus what? So this is the conception. I told you that I used to teach, I begin with simple examples because I have laid out the foundations, then I go to the more challenging examples. For this term, by using law of products, so remember the law of products, how does it state? So we say that log e of a, b, maybe base x, this is equal to what? Is equal to log of a base x plus log e of x base b. Log of b base x. So then we say 3 multiplied by what? 3 multiplied by log e of a square base a plus what? Log e of x base a. And this one is equal to what? Is equal to 0. Interesting. You see now how basic mathematical logarithms are very interesting. So then, if this is the case, we say that, but also third step, we say that, let us apply. So remember that the law here, we have used it, that we say log e of a times b, let's say base 10, this is equal to, even if it's what base what, let's say base x. So this is equal to log of a base x plus log of b base x. That's law of product. So again, she said that recall and apply. So recall and let us apply law of unity of logarithmic function, FCT. Which law? We say that log of a base a, this is equal to 1. Log of b base b is equal to 1. Log of 10 base 10 is equal to 1. Log of 10 base 20 is equal to 1. Log of 25 base 25 is equal to 1. So where should we apply? In this part of the second term and this part of the second term, right? So how? So it means that we say that this is equal to 2. We have 1 over what? Over log of x base a plus what? So here we have now 2 terms in denominator, and the first one is 1, as we said, log of a base a, and plus what? Log of x base a, plus, again we have what? 3, and then we have what? We have 1, divided by, here we are going to have 2 log of a base a, which is 2 times 1, plus what? Log of x base a, and hence all of these terms is equal to what? 0. Okay? So you see that now how logarithm is becoming interested, and this is for the basic technicians. Okay? So if this is the case, you say that here it will be 2 over what? Over log of x base a plus what? Plus 1 of what? Over 1 plus log of what? Log of x base a, then plus what? Plus 3 over 2 plus log of x base a. So from this point we find, first of all the logarithmic functions have the same base, but again have the same value. So the base is unknown and the value is unknown. So what do we expect? We expect that because we've been asked that to solve for x, we expect that the solution for the x, the solution for our x will be in terms of n. That's what you have to expect. So you go, so suppose that this is equal to what? Is equal to 0. And this is equation what? This will be equation what? This is equation 7. So we go for the third step. This was the first step. And the first step we say that we have to let us say log of x base a is equal to 1. Right? And then we substitute or replace whenever we have log of x base a with 1. Plus what? 1 over what? 1 plus what? 1 plus what? 3 over what? 2 plus 1. Alright? Okay. So this is equal to what, ladies and gentlemen? Is equal to 0. So, and this is what? Equation 4. So if this is equation 4, we say that now let us simplify. So this will be the fifth step. Let us simplify equation 4. So to simplify equation 4, we have first of all to find the LCM, which is y, 1 plus y times what? 2 plus 1. So listen carefully. So this is the LCM of these two, of this fractional algebraic function. So take this LCM divided by y, so you get that this is 2, then so you have 1 plus y times what? Times 2 plus y, then plus what? So these terms over these terms remains what? Y times 2 plus y plus what again? Again, so you take these terms over these terms is equal to y times 1 plus y, and all of these terms should be equal to 0. Right? Just to simplify, multiply by y times 1 plus y times 2 plus y both sides. So this one, these terms will cancel. So on this side we have 1, so we have, let's say, 2. 1 times 2, it is 2. 1 times y, it is y. 2 times y, it is 2y. So this makes 3y. Yes, y plus times y is equal to y squared. right? Have you understood? So we're expanding. Then here we say that plus what? Plus 2y, and then plus what? Y squared. And then here we have what? Y times 1 is y, then y squared is equal to 0. Right? So if this is the case, we say that this will make 4. So 4, so this will make 4 plus 6y plus 2y squared plus 2y squared, and hence plus what? 2y plus y squared plus y squared is equal to 0. So how many terms of y do you have? 3 terms. So this is 4y squared plus 6y plus 2y, 8y. 8y plus y, 9y. So 6y, 8y, 9y. Plus what? 4 plus what? So plus 4. This is equal to 0. And this will make what? Question 5. Make equation 5. Okay? So let's check it. Finally, we have 6y squared plus 11y plus 4. So let me check. Made a mistake somewhere. So 2y squared, then we say that we have what? Y squared. Oh, so here we have 3. Thank you, God. Thank you, my God. So we have 3. So this term will be 3y, minor correction. And then this term will be also plus 3y squared. 3y squared. So if that's the case, this will make what? This will make 3y, and this will make 3y squared. 3y squared. So if that's the case, 3y squared plus y squared is 4y squared plus 2y squared is equal to 6y squared, right? And then we have what? 3y plus 6y plus 2y. So makes what? 11y. So this is 11y, not 9y. And then we have only a constant term, which is 4. That's question 5. Okay, so we are still solving. We are looking for the value of x. Tell your neighbor, enjoy the field of basic engineering and scientific mathematics. So you can also pause. Once I write a question there, you can pause and try yourself, and then you go through, because I need active students. You have them doing mathematics on your own. So you go for the 6th step. The 6th step now, we say that solve equation what? 5 by using what? By using either general formula or scientific calculator. So let us use the scientific calculator because that is quadratic what? Quadratic function. So you do remember we have eliminated our quadratic function. So you have to change the mode of our scientific calculator into quadratic function. So you press for the first time compounds complex, second times standard deviation, registrations base, 30 times. You find the equations matrix vector. So choose the equations, press number 1. Then you have been asked the number for unknowns. We have some more than 1 unknowns. No, we have only 1 unknowns, but the highest degree is what is 2. So you select 2. What the coefficient of y squared is what is 6. You insert 6, you press equal sign. Then what the coefficient of y? It is 11. You set 11, then you press equal sign. Then what the coefficient of c? Coefficient of y power 0. It is 4. Then you get x1 is equal to negative 0.5. So we find that y1, which corresponding to x1 in the scientific calculator, this is equal to negative 0.5. And also x2 in your scientific calculator will correspond to the y2 in our, you press the equal sign, right? So you find it is negative 1.333 as a repeating decimal. Simply this one you can express as negative 4 over 3. So you have how many values? You have 2 values. And both values are what? Are negative values. So after getting that, we have to go back to our step 4, where we let x inverse a is equal to what? 1. So we say that we call our function, which was log of x inverse a, is equal to 1. Right? So we say that for this case, we say that log of x inverse a is equal to negative a half. What are we finding for? We are finding for the value of 40 of x. Okay. So this is when what? We say that when y is equal to negative a half. Okay. So the second, the seventh step. So let's say that this is equation 6. And also you have another equation, log of x inverse a, this is equal to negative 4 over 3. So this is equation 7, right? So we say that express. So this will be the 7th step. The 7th step, we say that express was equation 6 and equation 7 in what? In exponential form. In exponential form. So to express for this one, base will be a power negative a half is equal to what? X. Simply, this implies that x is equal to 1 over square root of a. This is the first value of x. The second value, if you express this one, it will be a base of a power negative 4 over 3. This is equal to what? X. So this one also is equivalent to what? This is equivalent to x is equal to a power negative 4 over 3, which is equal to a power negative 4 1/3. Right? 1/3. Okay, so we are about to finish these problems, and hence I will give you another problems. I'm about to end this session so that you have to stay focused. Okay, so we say that we have what? So the first one, x is equal to what? Is equal to 1 over square root of a. Right? And then the other one, we say that x is equal to what? A power negative 4 over 3. I told you that this is equal to what? A power 4, then power what? Negative 1 over 3. What does it mean? X is equal to what? X is equal to, we say that 1 over a power 4 power 1/3. This is equal to 1 over what? Over a power 4 cube root of that. Cube root of a power 4. So therefore, x is equal to what? 1 over square root of a, and all x is equal to what? If you test in this, all of these values, you will find that they satisfy the given logarithmic function. So this is your response right now. Right? Okay, so I'm about to end this lecture or this session. We will give you the homework. Let me give you the simple homework today. This will be homework 5. And this is example what? This is example 11. We did example 8, example 9, example 10. This is example 11. You have to do it for yourself. Let me give you today a simple question. Solve for x. Right? Solve for x. Solve for x, and here we have it. Log of x base 3 plus what? Log of x base 4. This is equal to what? 1 over log of 3 base e, and then plus what I taught you the meanings of e in lecture 3. So if you forgot the meaning of e, just to go to lecture 3. So okay, so for the value of x in these questions, make sure that you do this homework question 5 and submit your solutions in the comment section. Okay, so this is the end of lecture 5 of what problem solving in indices and the logarithmic functions for ordinary diploma. This is the beauty of basic engineering scientific mathematics. It's the queen of basic engineering and basic science, because that's what ordinary diploma they do use to learn. So I thank God who has created me in his image and likeness. I thank my God who have given me a gift of teaching. I thank my God who have given me great idea to teach national and international students through the internet. And I thank God who have been with me in the preparations of this lecture 5. And I thank God who have given you an opportunity to learn these contents with me. And I thank God because I know that through these contents and through online Diploma Polytechnic Institute of Tanzania, he is going to solve small-scale problems, large-scale problems, medium-scale problems, and even extraordinary large-scale problems in Tanzania, in Africa, and the worldwide. I would like to invite you in lecture 6 in Ultimate. I will keep on problem solving part 3, because lecture 4 is problem solving. Lecture 5 problem solving. Lecture 6 also I will be teaching you how you can solve some challenging logarithmic and exponential function, but we'll be focusing more in logarithmic function. So make sure that you subscribe into our YouTube channels. As I told you that we are going to have more than 300. Again, in case that you feel you have learned something, you have understood something that you've been roaming around for a long time, so that you fail to understand it, possibly from your classroom lecturer or your classroom tutorial assistants or your classroom assistant's lecture, then now if you have to give God thanks for what he brought to you in your hands at any times and also anywhere. So you may offer your free willing thanksgiving to God, not to me, through this program, in order for you to contribute the running cost for these programs, so that so many lectures of algebra will be in air for the present and future generation. So it's your seed offering. If you're parents that are watching, you're warmly welcome. And then make sure that you send on this telephone number or even the bank transactions, so that I and you will be working together for these contents to be out of me. And I don't want to go with them in the grave. I would like to pour them out. And may God bless you abundantly. I'm always praying for my online ordinary diploma students. I ask you also to do the same for me in order to accomplish this vision that you have received from our Father who is in heaven. So stay focused, stay thinking, think on your own how you can take all of this information that I've taught you in lecture 5 in order to solve real life problems, because that is the main objective of all of these instructions that we have taught you. Regardless that the history shows that many people didn't apply, but because they didn't want, because the logarithmic functions is applicable in the world. Possibly in Tanzania we don't apply, but it doesn't mean that logarithmic function does not have applications in the real life. The issue is we are satisfied with existing system and existing knowledge. But this is what God has told me, that we have to learn as the present and future generations to break the barriers and to change the culture. So may God bless you and see you in lecture 6. I love you so much, but God loves you more than me. May God keep you safe.